Welcome back to this series on trigonometry, and this is the second episode on trigonometric identities. The first one we saw sine square a plus cos square equal to 1, and in this episode we are going to look at the second identity, which is the tan square a plus 1 equal to secant square a. So we are going to see how we are going to approach questions related to this identity and what does it take to master this concept, right? I have divided it into three levels of understanding, right? So the first level being just memorizing tan square a plus 1 equal to secant square a, right? That is level 1, but we have to go to the next level. What does going to next level mean? If I rewrite this as secant square a equal to tan square a plus 1, I just swapped LHS and RHS, and if I get 1 onto the left hand side, it becomes secant square a minus 1 equal to tan square a. So not just memorizing tan square a plus 1 equal to secant square a, you should also be familiar to secant square a minus 1 equal to tan square a. Right? Not only that, instead of 1, if I get tan square a to the LHS, what happens? Secant square a minus tan square a equal to 1. So to reiterate, memorizing this and saying I have learned this concept is not enough. You need to upgrade it to level 2 where you are aware that secant square a minus 1 can be written as tan square a and secant square a minus tan square a is equal to 1. Apart from it, it doesn't stop there, right? If you see equation 1, this can be written as secant square a minus 1 square equal to tan square a. Does it ring a bell? Hopefully, it gives you an idea that secant a minus 1 into secant a plus 1 would become tan square a. So you saw secant square a minus 1, which is of the format a square minus b square. You wrote it as a minus b into a plus b. So secant a minus 1 into secant a plus 1 is equal to tan square a. Not just that, if you look at equation 2, you should realize that secant a minus tan a, same identity, a square minus b square into secant a plus tan a equal to 1. What does this mean? Again, not memorizing it, not memorizing this again. I'm not asking you to, instead of one identity, I'm not asking you to memorize 5 of them. I'm saying understand how it has been derived, and in a question, wherever you see this, or this, or this, any one of these, you should get an idea that maybe I can use one of these identities. So that is level 3 of understanding, where you're applying what you have learnt, or you're applying the basic fundamental identity in a new scenario, right? Let us look at few questions. Maybe that will help you understand what I'm trying to tell here. If you look at this question, I can see on the left hand side, secant square a can be taken common. Let me try doing that. What happens? LHS, I take secant square a common. What do I get? Secant square a minus 1, because secant power 4a will become secant square a and this will become 1, so secant square a minus 1. This should give you an idea that this is nothing but tan square a. So this becomes secant square a into tan square a. This is LHS. Let us look at RHS. RHS, I can see, I can take out tan square a common. What will become in the bracket? Tan square a plus 1. Again, tan square a, your level 1 of understanding where tan square a plus 1 is nothing but secant square a, tan square a into secant square a. Hence, LHS is equal to RHS. That's all, right? So, looking at the question, not just memorizing, you need to apply what you have understood. That is the crux of it. Let us look at one more question. Looks very scary because secant tan, then there is a denominator secant minus tan. I've seen many students simply having a thumb rule saying that whatever the question is, I'll convert everything into sine and cos. Right? Converting to sine and cos might help in many cases, but not always. Okay? Things can be done smartly. If you see secant theta plus tan theta, does it remind you of something? Have you seen it somewhere? Absolutely. Where did you see secant square theta minus tan square theta equal to 1, which essentially is secant theta minus tan theta into secant theta plus tan theta equal to 1. This is where you have seen this. Correct? So what I'm going to do is I'm going to multiply numerator and denominator by secant theta minus tan theta. That's what I'm going to do. Secant theta plus tan theta into secant theta minus tan theta by secant theta minus tan theta. This is LHS. Now simplifying the numerator, you'll get a plus b into a minus b secant square theta minus tan square theta by secant theta minus tan theta. What is numerator? Connecting it to this one, numerator is equal to 1. So 1 by secant theta minus tan theta, which is equal to RHS. Right? So again, a word of caution, a problem in trigonometric identities can have multiple paths of solving it or multiple approaches to solve it. I have shown just one of them. You can try converting everything into sine and cos, and you will understand the pain behind doing that. So converting everything into sine and cos might not be always advisable. There are better ways and you should watch out for the better ways. Right? Let us look at one more to again drive my point through. This is a scary looking question, square root, and then there is numerator, denominator in trigonometry. Looks scary, but again, where have you seen similar stuff? Where have you seen secant theta plus 1? Where have you seen secant theta minus 1? Does it ring a bell? If you remember, secant square theta minus 1 is tan square theta. So secant theta minus 1 and secant theta plus 1 is equal to tan square theta. Haven't we seen that? Right? What I'll do here is, in the first one, I'm going to multiply numerator and denominator by secant theta minus 1. Similarly, the second one, I'm going to multiply by secant theta plus 1 here. What this whole thing becomes is after the denominator becomes tan square theta from here, and here also the denominator becomes tan square theta. So overall, everything is perfect square. It boils down to secant theta minus 1 by tan theta plus secant theta plus 1 by tan theta. And if I simplify this, you are going to get 2 secant theta by tan theta, which on simplification you will get 2 cosecant theta. And that is equal to RHS. Right? Imagine if you don't remember this and you try to convert it to sine and cos. It's going to take, you might get the solution eventually, but instead of 5 minutes, it might take 20 to 25 minutes to solve it. And we know our time is precious during an exam. So I hope this helps. Thank you.